Methods of measuring the distances and ages of celestial objects in the universe, such as spectroscopy or measuring the light coming from celestial bodies. Measuring the distance and age of celestial objects in the universe is a crucial aspect of astronomy. Accurate measurements of distance and age are essential for understanding the evolution of the universe, the formation of galaxies, and the properties of individual stars and planets. In this article, we will explore some of the different methods used to measure the distance and age of celestial objects, including spectroscopic measurements and measurements of the light emitted by celestial objects. One of the most important methods for measuring the distance and age of celestial objects is spectroscopy. Spectroscopy is the study of the interaction between matter and electromagnetic radiation, such as light. By analyzing the spectrum of light emitted by a celestial object, astronomers can determine its distance and age, as well as its chemical composition and other physical properties. Spectroscopic measurements are based on the fact that different elements and molecules emit or absorb specific wavelengths of light. By analyzing the spectrum of light emitted by a celestial object, astronomers can identify the chemical elements and molecules present in the object. This information can then be used to determine the object's distance and age, based on its position and motion relative to the Earth. Another important method for measuring the distance and age of celestial objects is the measurement of the light emitted by these objects. The speed of light is constant, and the time it takes for light to travel from a celestial object to the Earth can be used to determine the object's distance. This method is known as the light-year method, and is commonly used to measure the distance of stars and other celestial objects. To measure the age of a celestial object, astronomers use a variety of different techniques, depending on the object in question. For example, the age of stars can be estimated by measuring the amount of certain radioactive elements present in the star and comparing it to the amount of these elements in the surrounding gas and dust clouds. The age of planets can be estimated by studying the geological features of the planet and comparing them to similar features on Earth. In addition to spectroscopy and measurements of light, astronomers also use other methods to measure the distance and age of celestial objects. One such method is the use of parallax measurements. Parallax is the apparent shift in the position of an object when viewed from different locations. By measuring the parallax of a celestial object from two different points in the Earth's orbit, astronomers can determine the object's distance from the Earth. The parallax method is particularly useful for measuring the distance of nearby stars. However, it becomes less accurate for more distant objects, as the angle of parallax becomes smaller and more difficult to measure. For more distant objects, astronomers often use other methods, such as the distance modulus method, which is based on the relationship between the apparent brightness of an object and its distance from the Earth. Another important method for measuring the age of celestial objects is the study of cosmic microwave background radiation, CMB. CMB is the afterglow of the Big Bang, and it provides a snapshot of the universe at its earliest stages. By studying the characteristics of CMB radiation, astronomers can determine the age of the universe and the properties of cosmic structures, such as galaxies and clusters of galaxies. The study of supernovae is another important method for measuring the distance and age of celestial objects. Supernovae are the explosive deaths of stars, and they can be used as standard candles for measuring cosmic distances. By studying the properties of supernovae, such as their brightness and spectra, astronomers can determine